Hello, it's Conner Holman again. I have made a couple of videos about figuring out what transformations should be done based on the equation, and so I wanted to go through and give you a couple of examples. So I went over this in a separate video, but I want to put it here. You can come back to it if you need to. When we talk about horizontal shrinking and vertical shrinking, and horizontal stretching and vertical stretching, here are a couple little diagrams that I drew up for this, so you can come back and pause and read it if you would like to. And here's yet another set of diagrams. So I envision having some, four-way stretch fabric and fix it on a frame and draw a picture and then push it towards the y-axis or pull it away from the y-axis, or push it towards the x-axis or pull it away from the x-axis, and think about what the resulting picture would look like. So I've used some examples from some old handouts. You may find these old handouts in my Google Drive folder if you wanted to look for even more examples. Okay, so here we have a function. G of x is quantity x plus 1, quantity squared, minus 3. And so first of all, I want to think of it in this way. I want to try to find an h and a k, so that if I take x minus h, that turns into an x plus 1, and my plus k turns into a negative 3. But if I rewrite this as x minus negative 1 quantity squared plus negative 3, then it will simplify into the function that I was given originally. So h is negative 1 and k is negative 3. If h is negative 1, that means we shift the graph left 1, and k being negative 3 tells us we're going to shift the graph down 3. So we have the graph here on the right hand side. In the red I have f, which is just the x squared graph, and g is the other graph. So get a little more abstract this time. We have a graph for some function f. I don't know what the equation is, but I now want to graph f of 1/2 x plus 2. So I look at my a times f of b times the quantity x minus h, n quantity plus k, and figure out what spot the 1/2 is in and what spot the 2 is in. So the 1/2 is in the b spot because it is multiplication inside. That's my b. And the 2 is added and it's outside, so my k is 2. So I know that my x's are going to get multiplied by the reciprocal of 1/2, which is 2. And we're going to add 2 to the y values. So you see that depending on what the context is, I use a different part of that overview. So what I've done is I took the original points on the graph. So I have the point negative 5, 5, and I have the point negative 2, negative 1, and 0, 3, and 3, negative 4, and 5, 2. And if I take negative 5 and multiply it by 2, I get negative 10. Negative 2 times 2 is negative 4. 0 times 2 is 0. 3 times 2 is 6. 5 times 2 is 10. And then I add 2 to the y values. So 5 plus 2 is 7. Negative 1 plus 2 is 1. 3 plus 2 is 5. Negative 4 plus 2 is negative 2. And 2 plus 2 is 4. So now I get this new set of points, and I can graph it. And notice that b being equal to 1/2, because the absolute value of b is smaller than 1, I know that it's going to be a stretch. And because it's inside, it's going to be a horizontal stretch. And k is positive, so that means it's going to be a vertical shift up. So we can look at the original graph and see if it looks like if we would stretch it horizontally and then shift it up, if this is what the new graph should look like. So we can see if our answer graph is reasonable, and if not, you can go back and look for mistakes. So for this function, negative 1/2 is multiplied outside. That means it's in the position of a. and 3 is being added inside, so I'm subtracting negative 3. So my h is going to be negative 3. That's the number after the minus sign. And my a is negative 1/2. That's the number out in front of f. So I go back to my overview and remind myself that negative 3 is going to get added to the x's, and my y values are going to get multiplied by negative 1/2. Again, I took all of the endpoints from the original graph. I took every single x value and added negative 3 to it. I took every y value and I multiplied it by negative 1/2. I get a graph that looks like that, hopefully. And then I can see if my graph is reasonable. So h equals negative 3 tells me that I expect a shift left 3. A equals negative 1/2. The absolute value of negative 1/2 is 1/2, and that is smaller than 1. So that tells me a vertical shrink. It was outside, so it was vertical. And because it's negative, I know that it's going to be a vertical reflection. So we take this thing, we flip it across the x-axis, we push it towards the x-axis, and then we shift it left 3. And so think about whether this is the graph that we should get out of that. So for example, if I take this point here and I shift it left 3, that point is, whoops, where'd my cursor go? That point's going to go 1, 2, 3. It's going to go over here. And then the y value there is 5. If I multiply 5 by negative 1/2, I get negative 2.5. So that's going to come out here. And so we see that point right there. You could do that for the rest of the points. Okay, so here's a slightly different question. So I'm given f of x equals 3 minus the absolute value of x. And so I can see that I can rewrite it as negative absolute value of x plus 3. And so this negative 1 out here is being multiplied outside. That means it's an a number. It's a value for a, which is negative 1. This number here is added outside, so my k is 3. And when a is negative 1, its absolute value is neither bigger than 1 nor smaller than 1, so there's no stretch or shrink. But since it's negative, that means it's going to be a vertical reflection. And so a vertical reflection is going to be across the x-axis. I hadn't caught that I had a mistake there. So it's going to go across the x-axis, and then it is going to go up 3. So if we wanted to, we could multiply all the y values by negative 1 because we use a to multiply the y values by. And we add k to the y values as well. So we add 3 to the y values, so I did that in 2 steps this time. If you plot those points, that's the graph that you should get. So hopefully it does look like it's across the x-axis and up 3. And that's all the examples I have for you for right now. Feel free to look at the handouts that I put in the transforming graph in Google Drive to find more examples. I have lots of different contexts of questions that we've applied transformations to. More than you need to do in this course, but it helps to look at things from different angles to make sure that you really know that you understand it. Talk to you later.